everyone. My name is Ghaziabad and I am an assistant professor in Computer Science and Engineering Department at ABES Engineering College. Welcome you all to the online session. Today we are going to learn about the LL1 parsing. Let's move. LL1 parsing comes under an top-down parsing method. There are two types of parsing. One is top-down and another one is bottom-up. Today we are going to see about the top-down parsing, in which we are going to learn about the LL1. Here, specifically here, two L's are mentioned. The first L signifies that we are scan the input symbol or the input given to us from left to right. For example, if we have an input symbol like ABB, for example, this is the input provided to us for the parsing. We are going to scan about the left to right. That is, first we are going to see the A, after that small b, and followed by small b. So first L signifies that we can scan the input from left to right. Second L means we derive the derivation tree in the leftmost term. There are two types of derivation tree. We know that in derivation tree, we have two types. One is leftmost, in which we see the leftmost variable or leftmost symbol the first, and another one is rightmost. First one is leftmost and the another one is rightmost. So in LL1 parsing, we are going to derive the leftmost derivation tree. And this one means we are going to see one symbol or one input at a time. For example, here, if we want to scan the input, we don't scan the input in one go like ABB. First, we see the A, then we check for the production. After that, we see the small b. That is, one by one, we see the input. Now, the current symbol, if let's see, the third point says, if my pointer is here on small a. So what I can say, the current processing symbol is called look ahead symbol. It means if here I'm scanning the small a at a time, this means this small a is our look ahead symbol. So we can see an example of LL1 parsing sum, then it's all the points will be clear. For example, this is our production, or this is the grammar given to us, for which we have to check that this set of production or grammar satisfy the LL1 parsing rule or not. For this, our first step is to calculate the first function and the follow function. In the previous session, we see how to calculate first and follow. For example, here for the production, for the symbol S, the first function will be here. S is the what? Starting symbol. So first of S will be small a. Okay. Then capital A. What will be the first of capital A? Either small c or epsilon. Then symbol B. What will be the first of B? Small d or epsilon. This will be the first function of this grammar. Now we have to calculate the follow function. How we will calculate the follow function? For the starting symbol S. S is what? Our starting symbol. S doesn't appear in any of the right hand production. So we can say that S is our starting symbol. So by default, dollar will be follow of it. Okay. Now we have to check for capital A. See, here capital A, which symbol follow capital A? Capital B. Capital B is a non-terminal. In case of non-terminal follow function, we have to check the first of B. So what is the first of B? Either D. So the first of B, the follow contain D, or when we put epsilon in the place of capital B, then A follow by small b. So follow of A will be A, or follow of A will be D or B. Now it's turn for capital B. So in capital B, the follow will be, I think, small b. See, here The capital B is the symbol. Which symbol follow the capital B? Small b. So we can directly write small b will be the follow symbol for capital B. So this is our first function and this is our follow function. Now this is our LL1. This is our LL1 parsing table. Now we have to fill this table. How we going to construct this table? Let's see. We have to first write the non-terminal symbol. Non-terminal symbol is that which will be produce the another production rule. For here, which symbol are produce the production rule? S, A and B. So here we write what? S, A and B. One second. So S, A and B. And these are our non-terminal symbols, small a, small b, C, D and dollar. Dollar is for our termination string. We have to include dollar also. So now let's see how to construct this parsing table. This is commonly known as LL1 parsing table. This table is known as LL1 parsing table. So we have to check capital S on small a. Okay, we have to check capital S on small a. So now we will see how to construct the LL1 parsing table. For construction of LL1 parsing table, we list out the non-terminal symbol in one side, that is capital S, capital A and capital B, and the terminal symbols small a, small b, C, D and dollar on the one side. Now for this construction of parsing table, LL1 parsing table, we have to see the first function firstly. For this, see what is the symbol here? Capital S. S contain the first function only small a, that is on seeing capital S we have the first function in symbol a. So we can here replace the production S tends to small a, capital B and B. How we can write it? Here S contain the first function as small a. So we can replace the production in this particular cell. Now here comes the capital A. For capital A, we have two symbols. First one is small c and the other one is epsilon. Whenever epsilon is come in the first function, we cannot directly write it. For examining the epsilon production, we have to check the corresponding follow function. See, here, what is the first symbol? Small c. So we can directly write the production A tends to small c in this particular cell. In this cell, capital A corresponding to small c, we can write A tends to small c. For the epsilon production, we cannot write here A tends to epsilon. For epsilon production, we have to check the particular or the corresponding follow symbol of A. Here, follow symbol of A contains small d and capital B. So, on capital A and small b, we can write A tends to epsilon. On D, we can write A tends to epsilon. Okay. Same in the case of B. For capital B, the first function is small d. See, on the capital B, the first function is small d first. So, we can write B tends to small d. And for the epsilon, we have to check the corresponding follow function. So, in corresponding follow function, what will be the symbol we are getting? Small b. So, on capital B and small b, we can write B tends to epsilon. So, this is our LL1 parsing table. So, now we can check upon an input string whether how the parsing table is constructed and how the LL1 parser is going to accept it or reject it. For example, this is our input symbol, small a followed by small d, d and dollar. This is the LL1 parsing table which we recently constructed, LL1 parsing table. Okay. So, for construction of or for checking of LL1 parsing table, we have first the input table, then we have the parsing table. Now we have the LL1 parser which contain a stack like this. In this stack, in the bottom we have the dollar symbol. Okay, this dollar is by default. Now we have the grammar like S tends to small a, capital A, B and B, A followed by C and epsilon, and B followed by D and epsilon. This is the grammar. Okay, this is the grammar on which we are working. So here S is the start symbol. So we first push the start symbol on the top of the stack. Okay. Now what is the symbol in top of the stack? Now we compare the top of the stack with one by one our input symbol. Now now my pointer or my look ahead symbol or look ahead header is on what? Small a. Now top of the stack is what? Capital S, and our pointer is point to or look ahead symbol is a. So on capital S, on seeing a, what we can do? We push the or we replace it the capital S by this particular production. So here what we can do, where here we copy the S and write the production by this particular cell in the reverse order. So first we put B, then capital B, then capital A, or then small a. This is our, now the stack contain A, small a, capital B and small b. Now top of the stack will be replaced by small a, and our look ahead symbol is small a. This small a and this small a is matching. Let us construct side by side parse tree. Whenever the top of the stack is popped off, whenever the top of stack is popped off or replaced, that means that particular symbol we are finalized. For example, on seeing capital S on A, we replace this production. So we can say that S is finalized for our parse tree. What is the production we are exchanged with S? S tends to small a, capital A, small b and capital B. Okay. Now on seeing small a and this a is matched, so we can say that this is matched. So we can pop it off. So we pop it off. Okay, pop it off. So we can say this edge or this branch is finalized. Okay, S tends to A is finalized. Now what is my top of the stack symbol? This is pop it off. Okay, let's erase it. Wait a second. Now, so this is no more. Okay, now my top of stack will be capital A, and my top of stack will be capital A. When the small a and small is matched, this A is cancel out with the small a, and my look ahead symbol on small d. On capital A, seeing small d. On capital A, seeing small d. On capital A, seeing small d, we can replace it by epsilon. Okay, we can replace it by epsilon. So in parse tree, we can replace it by epsilon. Epsilon is nothing. So now my top of the stack is capital B. Capital B on seeing small d. What is the action? Capital B on seeing small d. Capital B on seeing small d. This is the production. So capital B on seeing small d. That is, here we have to replace it by d. So now the top of the stack is small d and here d. So these two will be what? Match. So we can say pop it off. Now pop it off. Now we left with what? Small b, and the top of the stack is small b. So these two are also matching. So pop it off. Pop it off. Okay. So this is our what is parse tree. Now all the symbol is pop it off. So what we will left with? Only, so what will be left with? Only dollar symbol. This dollar and this dollar symbol is now matched. So we can say that after scanning the whole string, this dollar and this dollar is matched. So we can say that LL1 So we can say that LL1 parser is going to accept this particular grammar. Those grammar which are accepted by LL1 parsing table is also LL1 grammar. How to find that a particular grammar is LL1 or not? See, for that particular thing, this is our LL1 parsing table. If in a particular cell for a non-terminal and a terminal symbol, any two production comes in a single cell, then this is violates the rule of LL1 grammar. That means every single cell contain only one production at a time. So this is our LN1 parsing table. This is our stack. So what is basically the principle says after scanning the after scanning the input string, when dollar is matched with the stack symbol dollar and all these symbols are copied off, then we can say that parser is going to be accepted. Okay. So this is it for this lecture. We will see in the next lecture the other examples. So thank you all.